Hello, everyone. We are welcome to the fifth class out of 16 classes for the free training on data analytics and introduction to SQL and Python. So we're going to go into the training course now. For today's course, we're having a brief talk on artificial intelligence and how it affects the knowledge on data analytics. So I'm going to share my screen now and we'll go straight into the course. Yeah, so look forward to interesting moments with you in the course. You can put in your questions in the message area and you would sure receive an answer. Thank you. So we are talking on data and artificial intelligence, and our course objectives for today is to understand the terminology of artificial intelligence, popularly called AI, understand AI uses and its limitations, the different areas of AI, how to build AI into our data analytics project, and then how AI blends into some other popular devices known as IoT devices, Internet of Things. All of this, are part of the analytics process. So we'll be looking at that, and then we'll be having a discussion session. So for those who are watching online, you could initiate a discussion by putting up a question or a comment in the message box area. So here is the content for the discussion on AI. Right, so what is AI? AI is a very common buzzword. It's something we hear about in this time and age. People talk a lot about AI. AI in the simplest form is simply artificial intelligence, and that's intelligence built into an inanimate thing, into an object, into a machine, into a device. And of course, this intelligence is built by humans into these devices. So what enables this intelligence basically is softwares in forms of algorithms, models that are built into machines to enable them to act or behave intelligently, right? So artificial intelligence is just, intelligence built into machines, right? And this is an arm of computing science. It's an arm that was developed mainly by advancements in computer science that deals with the abstraction of human knowledge, human intelligence, looking at the logic of how humans think, and then abstracting that and programming that into devices that can act or that can initiate actions, right? So that is simply artificial intelligence, right? So looking at this image, you can see some form of abstraction of human intelligence into a kind of devices with, synapses and areas through which the logic travels to executing the action. So that's simply what artificial intelligence is. Just think of the two words that make up the buzzword, and then you'll be able to clearly understand what it is. So artificial intelligence is looked at in various classifications, and it's actually from the simplest to the complex. And really, what many of us are familiar with is what is known as the artificial narrow intelligence. The artificial narrow intelligence is sometimes is also perceived as weak intelligence. It is said to be weak because it can perform only one action. And though it can perform it expertly or very well. So intelligence built into a machine that makes it to be able to perform an action, right, in an expert or focused manner is artificial intelligence. So most of all the intelligence we see around us now is artificial intelligence. Talk of self-driving cars, right? It can perform a task of driving. Talk of your Siri on your mobile chats. It can perform intelligently the action of speaking, right? Of communicating, right? So even talk of machine learning tasks, right? Built into processes like your banking or like your social media, right? All these are as well narrow intelligence because they are programmed to perform a specific task, a focused task. So these are, artificial narrow intelligence. But it is believed that as artificial narrow intelligence continue to grow, humans can also begin to program machines or devices to be able to think or relate like humans. This is kind of more sophisticated because artificial general intelligence is looking at machines being able to act or do anything a human can do. And of course, humans are not programmed to perform just a task alone. They can do many tasks and they can do it simultaneously. They can do many tasks and they can decide on what tasks to do. They can do many tasks and they can also feel, right? They are tasks, their emotions, to their tasks. So the world of artificial intelligence, artificial narrow intelligence is also beginning to grow into the domain of artificial general intelligence, right? So in the domain of artificial intelligence, humans are now beginning to use complex algorithms to be able to help machines to decipher between many tasks, to be able to help machines to think like humans would think in deciding, in making decisions, in feeling emotions, right? So they make machines to learn different ways that human respond to motions and emotions, and then they kind of make those kind of machines as well to be able to perform several tasks in that regard. So there has been little or very few breakthroughs in that regard. One of the examples in that regard is the IBM Watson super intelligent machine, right? That is made to start to have algorithms that can extract motions and replicate such. We've also had um, some AI advancements that can respond to dancing and things like that. So just think of artificial general intelligence as doing mundane tasks that humans would do easily, because these things like dancing machine, so some robots are gaining traction in that regard, but these are not things that, a machine might be easily programmed to do, because those would involve, several actions and emotions attached to them, right? So it is something that, humans are beginning to, scientists are beginning to look into that. Oh, okay, let's move from the level of artificial narrow intelligence to general intelligence and to super intelligence built into machines, right? But right, for the times we are in, for this current trend of things, what is general? When people are talking about AI, most times the implementations that is being referred to are artificial narrow intelligence. So for you as a data analyst, what does this mean to you? It helps you to understand and to focus that in creating intelligence or machine learning products, you should make your task to focus on one specific task. You should make your you should look forward to achieving one specific task and, getting it, very getting the machine to do that specific task very well. Right. So I've explained this in detail. This is just telling us in more detail the difference between ANI and AGI. So one is built for specific problem solving, while the other is built to adapt to new knowledge and to reason, right? And to gain new knowledge from previous history of knowledge and even new data. So in the world in for AGI, for artificial general intelligence, we have interesting models like the reinforcement learning that are helping in that regard. We also have many other new learning in deep learning network that is helping in that regard. So this is an area that is beginning to evolve faster than we think of it, right? And according to research, it is expected that maybe by the year 2050, we'll have had artificial general intelligence in much more standardized forms around us. And we'll have machines that are able to perform this general intelligence with much more ease. Right, so we've talked a lot about artificial intelligence, right? We've also seen different ways of its implementation and mentioned several examples. I'm sure if you look around you, you would see several forms of implementation of AI around you. We've also mentioned many examples in AI since the beginning of this training course. So I'm sure AI will no longer be just a buzzword to you, but you'll be clear on the meaning of what AI is. Now, let's look at AI and machine learning. People use this concept, they use it almost together because most times the difference between them is not so clear. But we're just going to explain to you now what makes the difference between machine learning and AI. So machine learning is a technique used to achieve AI, right? So we want you to understand that artificial intelligence is broad. And just like it explains, or as the name sounds, it's any form of abstraction of intelligence into machines, right? So in achieving artificial intelligence, the concept for making machines to achieve artificial intelligence is to help machines to learn through data. So for humans now, you could learn how to carry out a task as a human through experience or exposure. If you're exposed to how a task is done, or you are, or over time you see how a task is done, then you as a human would um, gradually understand and adapt to carrying out the task. Right. So that same abstraction of how humans learn a way a task is done is the same abstraction that is used in the concept of machine learning. So in machine learning process, in data analytics, like we've learned in the data analytics process, the model is exposed to cleaned data. And then the model is expected to, learn the patterns, right, in the data. So once the pattern is learned, it uses the same algorithm, the same pattern to execute on new data, right? And then to be able to predict on the new data. So the same way, in machine learning concepts, the machine is made to learn. It could be in the area of carrying out a specific task, of predicting a classification on data. It could be carrying out a specific task of 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 making the machine to learn how to do a specific task very well, like in the case of self-driving cars. It could be like in the case of playing chess game, right? It could be in anything, but in a specific task. So to make that machine to do that specific task thoroughly, it is exposed in two ways, either by experience, learning by experience. So that's synonymous to exposing it to various forms of data, because it will learn from, data history, which is like experience gained over time, or by teaching it to do the task. So teaching it to do the task could be maybe by way of a set of rules that, okay, to do this task, do carry out instruction A, instruction B, instruction C to E to F, right? That's a set of rules. So machine learning is just a part of artificial intelligence that is a technique used to achieve artificial intelligence, right? So that's a clear difference between machine learning and AI. Then deep learning as well is a higher network. I think I've explained this in the previous class, that it is a much more deeper network or deeper steps of machine learning algorithm that is created by various complex forms of machine learning algorithms to create much deep understanding on the task that the machine is expected to do, right? So it's a deeper abstraction than machine learning, and it's fashioned after the way the brain network is built, looking at the brain as various network synapses and data or information or signals having to travel several steps before the information within it is extracted. So deep learning is just a much more complex form of machine learning. And all of these are used in achieving artificial intelligence. So I'm sure by the time we are going to the realm of much more deeper AGI or super intelligence, we'll be having some much more deeper learning to help in achieving that, right? So um, don't be carried away by the different buzz names that you hear, but just understand the clear difference and know how to apply it to any problem, to solving any problem as regards using any of these techniques. So this is just another representation of deep learning, machine learning, and artificial intelligence. And overall, what is used in achieving any of this is simply, the algorithms that are used to create the models, that are used to create the instructions, right? All of this run on algorithms. And algorithms remains the domain of computer science and in the area of building software. So you can see how important algorithms are. You can see how important the knowledge in the domain of computer science as well is for creating artificial intelligence. All the mathematical instructions, the statistical learning that we discussed in the previous class are abstracted into algorithms, right, on which artificial intelligence run to create knowledge. So for machine learning, we have different types of machine learning. We have the supervised learning, we have unsupervised learning, and we have reinforcement learning. This is also from the level of simple to complex. So in supervised learning, remember I said machine is made to learn from various exposures of data, right? So in supervised learning, the data is labeled, so it's easier for the machine to learn, right? So most of all that we treated in data analysis process, they are all supervised learning, because in labeling the data, you have indicated the various types of variables that the data is before exposing it to the algorithm. So you have labeled maybe one of the feature in the data as the outcome variable or the dependent variable. You have labeled some other ones as the independent variable. So it is clear already to the model that, okay, these are the various classifications of this model. So the algorithm model is just going to check within the data, just like a human tool would observe if it were a small set of data, right? So the algorithm would apply the statistical and mathematical principles, some of which we learned, and use that to create patterns on big data and learn and create his own model for which it will run on new data. So that's the case of supervised learning. Just understand that in supervised learning, the sets of inputs, which is usually data, right? It could be some other form of input. It could be images, it could be text, it could be anything. But the sets of inputs in supervised learning is labeled. That's what makes supervised learning different from unsupervised learning. However, in unsupervised learning, the set of inputs is not labeled, right? You just have different data values, right? Usually scattered on a data plane, on a Cartesian plane, yeah. In the abstraction form of it, the data values are scattered on an abstraction plane, and then the concept of neighborhood in statistics is used to cluster this data. So in clustering the data, it then begins to look at similarities or dissimilarities between the data, begins to use that to understand the patterns within the data. This is used in various forms of abstraction. It could be in data input. It helps us to discover new patterns in data inputs when we use unsupervised learning. It could also be in studying of new microscopic images, right? It has helped scientists to discover various new variants of different microorganisms and all that, using unsupervised learning. It's an ancient method of actually learning about data that was, abstracted as well into uh, computing using various statistical and mathematical concepts. So this is, very, the difference actually between supervised and unsupervised is that in unsupervised, the data is not labeled. So the algorithm is made to discover groups within the data and associate, the data using correlation. You can see here it detects the correlation amongst the variables, and then it uses clustering groups similar to variables, right, to associate and filter on the data. So performing unsupervised learning on big data could actually be very cumbersome, and it will require a lot of capacity and all that, machine capacity, but is a very, very interesting way of having new discoveries within data, right? Then the third one is the reinforcement learning. So in reinforcement learning, a machine is made to independently respond to external new data, right? So based on new data that it receives, it readjusts in its model, and the new model is then used again to work on the set of data. So it's more of a generative kind of model, right? That is as well useful in machine learning. Okay, so having seen artificial intelligence, machine learning models used as a technique in artificial intelligence, we can see that, right, it has been used in various forms in different industries all around us. You can see its impact in productivity in organizations, right? Applying machine learning models on their data has helped them to learn about their data and understand new ways of applying the knowledge gained from the data on creating new products, right? So based on the features on their data, like the fashion industry, for instance, now has used things like machine learning models to come up with newer fashion trends and newer fashion models based on history of different fashion data exposed to a model. We can also see the impact on producing companies. So producing companies, sometimes come up with what we call product mix. So in product mix, based on features of a product, and based on the significance of the correlation of some features of a product, that's how important people perceive certain features of products. Some companies are able to detect those significance from field data on the sales of their products. So they use those features merged from different products to create new products. And that way, they generate more sales. So there's a lot of artificial intelligence, going on with the data in many production companies in that regard, right? It could also be in increasing productivity sales for enterprise organization. We've seen that implemented in many ways, like looking at the factors that affect sales. And then once you're able to learn that from your data, you can know what factor to adjust towards increasing sales. And for instance, a common example is things like price discrimination. Many air ticketing companies have been able to understand their data patterns and futures based on history of ticket sales. And then sometimes you just notice that within certain seasons of the year, there is a big drop in ticket sales. It's not that they don't want to maximize profits, but they've been able to understand the trend in the sales of their data and then use that to buffer up on different seasons within the year so as to increase productivity, right? We can also see the impact on employment, of course, with machine learning and artificial intelligence and general automation, right? We have seen machines being able to carry out more tasks and, of course, do it effectively. That way, we wouldn't want to say that people are being disengaged from their work. Rather, people are being, machines are taking over routine processes while humans are then beginning to gain new knowledge to be able to carry out their tasks more effectively. So in that regard, humans are shifting away from certain job functions or certain ways of doing their job and are shifting to a new way, a new, much more innovative way of doing their job. For instance, we could have more machines taking over the place of a bank teller. So now with the use of automated teller machines, we have fewer people going into the banking hall. Then we now have teller staff being converted more into back-end staff that are just checking on transactions and allowing transactions to go through, just doing like a second check. So humans are now being, changed into performing some much more innovative tasks as against doing routine tasks that are generally boring for humans to do. But machines would, of course, definitely perform those tasks very well without complaining. We can also see the impact on agriculture. AI helping to improve on various agricultural outputs. Even AI being embedded into machines and AI algorithm being embedded into machines, and then it's able to detect certain nutrient deficits in certain plants, especially when there's agricultural activity or farming activity done on a wide expanse of land. So machines are able to travel faster distances and be able to carry out more tasks. Like in the case of drones, we've had drones being helpful in creating, much more better output on the farmland based on the activities they are programmed to do. Like certain drones are made to apply some chemicals that would reduce on agricultural disasters of maybe fly or pest infestation on the land, right? So impacts of AI is really across many industries and in various forms. We've also seen it in business competition, AI helping businesses to gain competitive advantage over their peers based on decisions they make on their data and information they're able to extract from their competitors' data, right? So the list of the impacts of AI is really endless, and I'm sure you can look within your domain as well and write within the message box how you think AI has impacted or is impacting or will impact your own domain as well. Okay, so lastly on this module, we are going to look at AI and Internet of Things. Internet of Things are basically sensor devices that create intelligence. And these sensor devices, of course, are not intelligent on their own. They are programmed by algorithms, right, to be intelligent. And these sensor devices as well connect into some other tools or softwares for either receiving data and algorithm, and also for also outputting data as well. We've seen sensor devices used a lot for collecting data information, especially on the field, right? We talked about sensors for collecting temperature rating on the field for weather forecast, right? So IoT devices are very interconnected with AI. In fact, AI actually, increased the usage of IoT devices, right? And now IoT devices are not just, um, performing simple tasks, but can also do much more complex tasks. We have several, IoT devices embedded together to making a self-driving car, right? In a self-driving car, of course, which would have sensors that can detect moving objects that are close to the vehicle so as to avoid any form of collision. We'll have moving objects, we'll have sensor devices within the vehicle that can also detect that a passenger has gotten into the car and is trying to move. So you can just imagine all the various sensors and sensor devices that are used in the world of AI and how AI has impacted IoT. So you can see on my image here, you can see IoT, AI and IoT blended. So in the times and seasons that we are in the fourth industrial revolution, a lot of productivity, right, has been created. A lot of innovations has been created based on AI and IoT devices. So IoT actually matters in learning about artificial intelligence. So we're going to stop now and have a quick discussion and then move on to the next class. Thank you for staying with me.